our discussions into bond polarity part 3, polymolecular. So in the previous video, you have what we call it B molecular sorry, B molecular. It means the molecule is only consists of two atoms. Uh, in here you can see HBr is two atom, H2O is three, so this is two, this is three, this is four, this is also two. So according to the your previous video, you only can answer HBr and HCl in terms of determining the polarity and stuff. So let's start with 2 and 4, HBr. So HBr, is it polar or not? Let's see. The hydrogen is 2.1, and then as you can see in here, the bromine is 2.8, right? So it's gonna be, wait, what is this? 0. Point 0.7 lah. So this is gonna be polar. Why? As you can see, it's more than 0.4. And then the NaCl, the Na is actually zero point 0.9, and then the Cl is actually 3.0, so the difference will be 2.1. 2.1, take a look at this one, it's going to be ionic. So it confirmed our last theory that this is metal and then this is non-metal. That's why it's going to be ionic. In the ionic, the lumper is not shared. It's just given. Like the lumper will be like, okay, I don't really need this. Maybe this is like more extreme condition. For example, Abian, Abian already got the breakfast. Abian do not forget the lunch box, the snack box. But Fondi in the opposite side forgot to bring the lunch box and also forgot to take his breakfast. So at the end, like I mean, like okay, I'm okay. You can have the lumper at all. Like I mean, I'm okay with that. I'm I still have my snack, something like that. So this is just give electron. So to give the lumper. So but in an ACL, you don't call it polar or non-polar. So polar and non-polar is actually describing covalent. It's still sharing, but some of them is not equal. But the NaCl is in here is not sharing. It's just giving the electron entirely, giving the lumper entirely. So that's easy now. But how about this one? Well, for the atom that more than so sorry for the molecule that has more than two atoms, it's actually a little bit complicated, and it's need a geometry of molecule. Since you are going to skip the geometry of molecule due to the time limit that we have, so you don't you I will just give you the a shortcut to it. This shortcut will apply to most of the cases, but I will also will not give you those special cases that the shortcut will not work. So basically, the shortcut will be to determining the polarity of polymolecular, the molecule that consists more than two atoms. What you need to do is, this is the key. If there is lone pair of electron in the center of atom, then the molecule will be polar. So the opposite words, yeah, you just need to write by yourself, yeah. So if there is no lone pair electrons, it means in the center of atom, yeah, it means it's going to be non-polar. So let's see, H2O, let's just break down here, yeah. H2O, we have to find out the electron in the center of atom. To do that, you need dot and cross. Okay, dot and cross. Remember, the first step of dot and cross is determine the center of atom. This is going to be oxygen, and this is going to be hydrogen and hydrogen. And hydrogen has the next step is drawing the electron valence of surrounded electron, which is hydrogen, had one. And then the third step will be making the surrounded electron stable, in this case duplet of hydrogen. So need one electron from oxygen, one electron from oxygen. So oxygen has six electrons since oxygen located in group 6. So because it's already shared two electrons to hydrogen, the remaining will be four. One, two, three, four. Okay, so now take a look at this one. This is the dot and cross structure. The oxygen is the center of atom and it has two lone pair. Lone pair is the electron that is not shared. So these two lone pair indicating that H2O or water is polar molecule. Okay. Now next one, NH3. If you want to know why, then you have to like have additional lesson with me because it will include the geometry and stuff. So NH3. N is the center of atom obviously, and there is H3. Okay, that's the first step of drawing dot and cross. And then you will have to draw the electron valence of surrounded electron, which is hydrogen. This is one and one and one. And each hydrogen needs one electron taken or no, shared from nitrogen. Nitrogen is located in group 5. So nitrogen will have, oh no. So nitrogen will have 5 electrons because nitrogen is in a group 5. So because it's already shared 3 electrons to hydrogen, so the remaining will be 2 electrons. So that's why these 2 electron or one pair will be considered lone pair. This is lone pair. So that's why NH3 ammonia is also polar. Okay. What is the example of non-polar? Well, let's see. If I have, for example, wait a second. Okay, if I have this CH3, CH2, sorry, CH3, CH3. Yep. CH3, CH3 is what we call it ethane. Okay. Ethane is the compound that you burn every day. This is gonna be the component of LPG. Okay, let's see CH3, CH3 polar or not. So the carbon, as I said before, just follow the formula. There is carbon number one and carbon number two. Carbon number one surrounded by three hydrogens, something like this. And then carbon number two will also surrounded by three hydrogens, something like this. And then the next step will be drawing the electron valence of surrounded electron, which is hydrogen. So you get one, one, and one, and one, and one, and one. And then this hydrogen need one electron each. So give one electron, one electron. This carbon number one has one more electron because it's, as you remember, carbon will be coming from group 4. So this one electron then shared to the carbon number 2. This is the sharing from carbon number 2, one electron, one electron, and one electron, and one electron. So as you can see here, carbon as the carbon is the center of atom, and there is no there is no lone pair. So that's why we consider them non-polar. Okay, so that's non-polar. Let's have another. So where there is the extreme, actually, when one structure they actually have two possible feature. They can both be polar and non-polar. How that possible? Well, yeah. Let's see. If I have, for example, let's say I have propanol. Propanol is also the alcohol type of alcohol that is in your hand sanitizer. Well, usually they in term of isopropyl alcohol, but just let's say propanol. The structure will be CH3 and then CH2 and then CH2 and then OH. Prop referring to three carbon. So you have three carbon in there. So let's draw the Lewis structure of it. As I said before, just follow the formula. This is carbon number one, carbon number two. I think I write it not appropriately. Wait. Wait. I supposed to give number carbon numbering of the carbon starting from the oxygen side. So it's gonna be carbon number one, carbon number two, carbon number three. Okay, carbon number three, they have three. It has it has three hydrogens surrounded, and then carbon number two has two carbons surrounded, and then carbon number three has two also, but has oxygen and also hydrogen in it. So as usual, just give everything in here. Okay, I'm not gonna okay, this and this. So after that, you will see every of hydrogen will take one electron from carbon, and this is the, the remaining one. And then let me change the color. The carbon number two is the blue one, so this is going to be sharing with the carbon number one. This hydrogen, and the third carbon. Sorry, yeah, the carbon number one, and then this is the electron, this is the electron, this is the electron, and this is the electron. And then the oxygen, let's give color blue again. The oxygen is be like this, and then like this, six. So there are four more. One, two, three, four. As you can see in here, um, well, this part, the center of atom is actually carbon, and all of them is actually the electron of them. All of them is actually shared. So the carbon has no electron, sorry, lone pair electron, no lone pair electron. But this is the also the center of atom. Oxygen, it has um, four, I mean two pair of electrons. And if you consider oxygen and hydrogen different in electronegativity also quite huge, it's 2.1, and oxygen is to I think 3.0. Yeah, 3.0. So this is 0.9. So there will be polarity in here because oxygen has also lone pair, and the electronegativity is also more than 0.4. So you will expect there is partially negative in oxygen, partially positive in here. But this rest of the structure will be equally shared. So this is going to be non-polar side, and this is going to be the polar side. The polar side. Well, if you have longer carbon chains, carbon hydrogen chains, then you will expect the non-polar will be longer also. So that will be the example. Another example is actually in soap. It's really really unique because the soap is actually there are two parts. This is oxygen. This is sorry, you will not understand that. I think you will understand that because double bond is already being discussed. This is oxygen and this is sodium, and this later on I will just draw this super long, and this is carbon 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 hydrogen bonding. Carbon, carbon, all of them is just, all of this is just carbon. Basically, if you imagine this you imagine to become that. We call it, this is the tail and this is the head. Okay. The tail will be non-polar. Okay. We call it hydrophobic. Why? Hydrophobic means hate water. Why hate water? Because water is polar and this one is non-polar. So they kind of they will not what we call it, agree upon each other. They will basically just separate it. It's like you have oil and you put it in a water, they will just separately. So that's hydrophobic. So the tail will be hydrophobic. As you imagine, it's just the longer version of this tail in the propanol. And this is going to be interesting. This is going to be interesting. First of all, Na is a metal. So you will expect metal, and oxygen is non-metal, right? oxygen is non-metal. So we will expect the difference of electronegativity between oxygen and sodium will be very high because non-metal and metal is supposed to have ionic bonding. That's why it's going to be breakdown in here. So the sodium will just give electron, one electron. So later on, what will happen is um, wait, so this C and then this is O and then this is oxygen and then this is the tail. Okay, I mean the tail is just carbon hydrogen bonding. So because of the electronegativity, sodium will just give electron to oxygen. It's going to be negative charge, and then sodium will be positive charge. Remember, this is a permanent charge. This is a permanent charge. Why? Because the difference of electronegativity between sodium and oxygen is really high. Mm, maybe let's just calculate in a very actual value because we have the data in here. Wait, sodium I forgot. Sodium I think sodium is 0.9 and then oxygen is 3.5. Yeah, 0.9 and 3.5. Okay, so it's supposed to be in here. So this is 3.5 and then the sodium will be 0.9. So the difference will be guys help me. I think, oh my God, 3.5, 0.9. This is gonna be 15 to, I'm gonna be embarrassed about this one. It's gonna be 6 and it's gonna be 2. Oh, guys, this is 2.6, right? Yeah. 2.6 different. Of course, if you remember the boundary of uh, ionic bonding is 1.8, right? So this is like more than 1.8. That's why this is going to be breakdown. It's not sharing again. It's going to be ionic. So it's just sodium will just give electron to oxygen. So this is also going to be a permanent charge because electron will not move to sodium again, right? So this is going to be permanent charge. This is ionic bonding. This is ionic, okay? But if you can see in the second oxygen in here, this is structure of soap by the way. So oxygen and carbon, well, oxygen tadi 3.5 ya, 3.5, and then carbon is I think 2.5, yeah. Carbon is 2.5, so the difference will be 1. 1 is considered polar. Remember, polar is 0.4 until 1.9, right? So this is polar. So we'll expect the moment dipole will be, let's change the color. Let's change the color, something like that. So this is the moment dipole. So we'll expect they're going partially negative in here and partially positive in here. So that's polar, right? So the soap has three um, type of bonding in there in one. That's why soap is very powerful. Okay, so in conclusion, soap will the head of the soap. Oops, sorry. So if you have this one and this one and this is the tail, it will have non-polar in the tail, in its tail, non-polar tail, and then the head will be both. Oh, sorry, this is partially negative and this is partially positive. The this is gonna be the polar part, and then this is gonna be the iron part. So they have three combo. That's why soap is very powerful, and it's gonna be related to your summative assessment later on. Okay, I think that's all for this video. See you on the next video, guys. Bye.